Hello students, we are going to start the topic called as aldehydes, ketones and carboxylic acids. Now, organic compounds containing carbon oxygen double bond, that is C double bond O, as a functional group are collectively called carbonyl compound. Examples: aldehydes, ketones, carboxylic acids and their derivatives. Now, general formula of aldehydes. That is R C double bond O H or CN H2NO. In aldehydes, the carbonyl group is linked to two hydrogen or one hydrogen and one carbon containing alkyl aryl or alkyl group. Example: H C double bond O H, CH3 C double bond O H, pH C double bond O H, pH CH2 C double bond O and H. So the name of these compounds will be discussed. So here we can see that this is the carbonyl group and it is having two hydrogen atoms linked here. So already I have told you in the earlier part, in aldehydes the carbonyl group is linked to two hydrogen or one hydrogen and one carbon containing. Now you can see that here there is one hydrogen and one carbon containing. This is an alkyl group, that is here. This is an aryl group, that is represented here, or an alkyl group, that is alkyl group is present along with what? Aryl group. Together we call it as what? Alkyl group. So there are two hydrogens that we write here. Here there is one hydrogen and one carbon, but that carbon is alkyl group. Here there is one hydrogen and one carbon, but that carbon is which type of carbon? Aryl carbon. And here we are having one hydrogen and one carbon, but that carbon is alkyl. Now the name of this compound is formaldehyde. Here we are having the name called as acetaldehyde, and here the name is called as benzaldehyde, and to this we are having phenyl acetaldehyde. In ketones, carbonyl group is linked to two carbon containing groups which may be same or different. Either alkyl or aryl or alkyl. And the general formula of ketones is R C double bond O R dash. If R is equal to R dash, it is symmetrical ketone. And if R is not equal to R dash, then it is unsymmetrical ketone. Let us have some examples. So the name of this compound is called dimethyl ketone. It is called as symmetrical. It is called as symmetrical just because we are having here two alkyl groups which are similar. Another example, now this compound is called as ethyl methyl ketone. I call it as ethyl first, then followed by methyl, just because alphabetically E comes first, so therefore I go with ethyl, then followed by what? Methyl. So therefore the name of the compound is ethyl methyl ketone. But since this group and this group are not same, so therefore we call this compound as unsymmetrical ketone. Let us have another example. Now this commonly is known as acetophenone, and it is an example of mixed ketone, just because here we are having alkyl group and here we are having aryl group, so therefore alkyl and aryl, so therefore it is called as mixed ketone. But here we can see that this is methyl, this is methyl, both are alkyl. This is alkyl and even this also is alkyl, but it is unsymmetrical. Next we will move towards nomenclature. Common names of aldehydes are derived from the name of corresponding carboxylic acids to which they are oxidized. And the suffix IC is replaced by aldehyde. Let us have some examples. So the name of this compound is called formaldehyde. But actually this compound, when subjected to oxidation, it gives formic acid. Now since this compound formaldehyde on oxidation it was giving formic acid, so therefore the name of this compound is now called as what? Formaldehyde. Similarly, let us have another example. This compound is called acetaldehyde. But this compound on oxidation it gave acetic acid, and we know the formula of acetic acid, CH3 C double bond O OH. Now if we were not knowing the name of this compound, and suppose if we had been subjected to oxidation, then it would have been given this compound. So therefore this compound is acetic acid, and when it is acetic acid, the name of this compound is now called as what? Acetaldehyde. Let us have another example. Though there are 3 carbon atoms, so therefore it is called as. Let us first write when this compound is subjected to oxidation, then what will we get? Since an aldehyde on oxidation gives carboxylic acid, since there are 3 carbon atoms, the name of the compound on oxidation, then we will get propionic acid, and propionic acid is having the formula CH3 CH2 C double bond O, then followed by OH. Then obviously the name of this compound would have been PIONALDEHYD, that is propionaldehyde. Next, in substituted aldehydes, the positions of the substituents can be indicated by Greek numerals alpha, beta, gamma. Likewise, starting from the carbon next to aldehydic group, that is now this is the functional group aldehyde, and here we are having alpha carbon, this is beta carbon, and this is gamma carbon. If a substituent is present at alpha carbon, suppose if it is what CH3, then we will call it as alpha methyl. Then depending upon the number of carbon atoms, we can name it as, if there are 4 carbon atoms, it is called as alpha methyl butanaldehyde. Now let us move towards IUPAC nomenclature. In IUPAC system, these are called alkenyl. And the names are obtained by replacing the suffix E of alkane by Al. Now this you have to remember, the suffix E of the alkane is replaced by Al. Now let us have some formula, common name and IUPAC name. Formula common name and IUPAC. First example, H C double bond O H. Common name of this compound is called formaldehyde. Since there is only one carbon atom present in this compound, so therefore I would like to write it as what the derivative of alkane, that is methane. But the functional group we have, that is what C double bond OH in the compound, right? So therefore such type of organic compounds having the functional group will end with the suffix, that is what Al. So therefore we are supposed to eliminate the E of this methane and write there Al. So therefore the compound name becomes methanol. Second example, CH3 C double bond OH. There are two carbon atoms. Common name of this compound is called acetaldehyde. And IUPAC name becomes two carbon atom, then the root word is called as ith, and we are having the suffix Al in the place of E. Third example, CH3 CH2 C double bond OH. So three carbon atom, so the name of this compound is propionaldehyde. And IUPAC name becomes propanol. The next compound, that is 4 carbon, CH3 CH2 CH2 C double bond OH. So therefore this compound is called butyraldehyde. And IUPAC name is butanol. Next we are having a substituent CH3 CH single bond CH3 C double bond O and H. So here this part is called as iso. So total number of carbon atoms in this compound are 4, that is 1 carbon, 2 carbon, 3 carbon and 4 carbon. So therefore the name of this compound is isobutyraldehyde. And the IUPAC name becomes 2-methylpropanol. So 2-methylpropanol. So if I just write it here for our understanding, so let us write it and try to understand. Always numbering is done in such a way such that the functional group should be getting what? The highest priority. So therefore this is the functional group. Let me write it as carbon as 1, and this becomes second carbon, and this becomes third carbon. So this is the longest chain. But at second position we are having a substituent that is called as methyl. So therefore the name of this compound becomes 2-methyl propanol. The next compound CH3, CH2, CH, then followed by CH3, then followed by C double bond O H. So common nomenclature, so here we write this as alpha, and to this alpha we are having a methyl group, so therefore this becomes alpha methyl butyraldehyde. And the IUPAC name becomes 2-methyl butanol. Next example, CH3, CH, CH3, CH2, C double bond O and H. Now here this is alpha carbon, this is beta carbon, and beta carbon is having a substituent, so therefore it is called as beta methyl butyraldehyde. And the IUPAC name becomes 3-methyl butanol. So the next compound will be now CH2 double bond CH, single bond C double bond O and H. The common name of this compound is acrolein. And if you see the nomenclature of this, preference is given for this functional group, which we are having number 1, and this becomes number 2, and this becomes number 3. So totally there are 3 carbon atoms, so therefore the root word becomes prop. And since there is another substituent which becomes secondary functional group, so therefore we'll write it prop 2 En, then followed by Al. Next example, CH3, CH double bond CH, then followed by C double bond single bond H. Now the name of this compound in trivial is called crotonaldehyde. And if you see the IUPAC name, we are having functional group C double bond OH, so this gets greater priority, 1 carbon, second one, third one, and this becomes fourth one. So therefore the name becomes but 2 in all. Next compound CH3, CH2, CH, C double bond O, single bond H, single bond CH, double bond CH, single bond CH3. As we move to higher organic compounds, the common names are less available, and we straight away write sometimes only the IUPAC name. And if you see here, we are having the principal functional group C double bond OH here, so therefore numbering starts from this carbon. So this is the first carbon, this is the second carbon. So now it is very important for us to move towards right side, because on moving right side we are having more number of carbon atoms, and that becomes the longest carbon chain, including the secondary functional group. Third carbon, fourth carbon, and fifth carbon, and on the second carbon we are having a substituent, and that substituent is nothing but called as ethyl. So therefore the IUPAC name of this compound is 2-ethyl pent 3-enal. That is, at second carbon we are having ethyl group, and if you see from here 1 2 3 4 5, we are having 5 carbon, and in this 5 carbon there is a double bond present at third carbon which is ending at fourth carbon. So therefore we will write it as pent 3-enal. CH3 C CH3 CH3 CH OH CH2 C double bond O and H. If you see in this compound we are having the functional group C double bond OH, that is aldehyde, which is having greater priority, and the second one, that is what, OH, which is called as what, hydroxy. So therefore on a numbering we have to start numbering from this carbon 1, so this becomes 2, this becomes 3, this becomes 4, and this becomes 5. Either we can move towards this side or this side, that will make 5 carbon atoms. So the IUPAC name of this compound is 3-hydroxy 4,4 dimethyl pentanal. The next example, CH3 CH CH3 CH Br, then C double bond OH. Numbering starts from this functional group, so therefore number 1 is given for carbonyl group, then second carbon, third carbon, and fourth carbon. So at second position we are having another substituent which is called as what, Br, but it starts with alphabet B, so therefore it is called as bromo. But here we are having methyl, so between methyl and bromine alphabetically Br comes first, so therefore we write it as what, 2-bromo 3-methyl butanal. Next example, CH3 CH2 3 times, then C double bond OH. So here we are having the functional group C double bond OH. So this is first carbon, and then followed by CH2 how many times? 3 times. 3 plus 1 4, 4 plus 1 5. So there are 5 carbon atoms. For such type of compounds we are having a common name, and therefore common name of this compound is N-valeraldehyde. And if this compound is subjected to oxidation, then we will get a carboxylic acid, and that carboxylic acid is called as N-valeric acid. But if you see the IUPAC name of this carbon, totally there are 5 carbon atoms, so the name of this compound becomes pentanal. And here we write N. N stands for what? A straight chain. It means there is no branching. That is called as normal. So we sometimes write N, and that N refers to what? Normal, which reveals that what? There is no branching. Next example, CH3 CH CH3, then followed by CH2, then C double bond O and H. So in this compound totally there are 5 carbon atoms, and those 5 carbon atoms are 1, 2, 3, 4, 5, and commonly we can write it as water. Already once I have told this. Now this group is called as iso, so isovaleraldehyde will be the common name. And the IUPAC name becomes 3-methyl butanol. In aromatic aldehydes, the CHO group is attached to the ring. In such case, the parent member is called benzaldehyde. And other members are called substituted aromatic aldehydes. Now let us have some typical examples. Now this compound CHO is called benzaldehyde. Now here we know that this compound is called as benzaldehyde, but on the other hand we are having here OH, so therefore it is called as substituted benzaldehyde. And in our earlier class we have already learnt that if this is the functional group, CHO is the functional group, when compared with OH, CHO group is having higher priority when compared with OH, and in such cases we say that there are some typical namings. Let me briefly introduce here. So if this is the functional group, now this carbon and this carbon we call them as orthocarbon atom, but whereas these two carbon are called as what? Metacarbon, and this is called as paracarbon. In fact we call them as positions. So ortho positions very immediate to this position, that is what CHO, the functional group. The next immediate two positions of this ring are called as orthocarbon, and the next two immediate after ortho are called as meta position, and the last one is called as para position. Now we should keep in our mind that the CHO group must not always be present only at this carbon atom, it can be present anywhere. So all you have to remember is that the position next to the functional group are called as ortho. Now this becomes ortho and this becomes ortho, and the next two immediate are called as meta, and the last one is called as what? Para. Now the same functional group which is present here, it might be also present at what other positions on the benzene. That is, if it is present here CHO, now this position and this position is called as ortho, then the next two immediate are called as meta position, and the last one is called as para position, right? Now the name of this compound is called orthohydroxybenzaldehyde. Or it is also called as what? 2-hydroxybenzaldehyde. And it is even having another name that is called as salicyl aldehyde. So I just wanted to make you know that now this 2, so this is the first carbon on the benzene which is having CHO, and this becomes second carbon, and this becomes third carbon, this is fourth carbon, this is fifth carbon, and this is sixth carbon. So therefore it is called as 2-hydroxybenzaldehyde. Next example, now this is benzaldehyde, and I will write the numberings. So therefore 1, 2, 3, 4 and 5. If a nitro group is present on second carbon, then it is called as 2-nitrobenzaldehyde, and if I write at third position as NO2, we know that CHO group is having greater priority and NO2 group is nothing but as a substituent. So therefore the name of the compound is metanitrobenzaldehyde. Or we can also write it as 3-nitrobenzaldehyde. Next example, CHO, and here I will write it as OCH3. In fact, we have to remember that this OCH3 is called as methoxy group. OCH3 is called as methoxy group, and if this methoxy group is present directly on benzene, then this compound is called as anisole. Anisole, A-N-I-S-O-E-L-E, anisole, or simply called as methoxybenzene. But when this only functional group is present along with what aldehyde, that is C double bond OH, then C double bond OH will be having greater priority when compared with what? Methoxy group. Under such condition, methoxy group will be acting as what? Substituent. So now again we have to give numbering for aldehyde group only, that is here 1, here 2, here 3, 4, 5 and 6. And we have to remember, we have to do the numbering in such a way such that the substituent should also get what? Lowest possible number. On moving in this direction, then we say that this methoxy group is having number 3. But on the same side, if we move in this direction, then the methoxy group will be having number 6. So therefore it is very important for us to move in a clockwise direction so as to get number 3 for methoxy group. So therefore the name of this compound is called as 3-methoxybenzaldehyde. Or common name, one more is possible, that is meta-anisaldehyde. Now another example, CHO and CH3. So when we do numbering, so this becomes 1 2 3 4 5 6. Either you do in clockwise or in anti-clockwise. This methyl group is having number 4, so therefore the name of this compound becomes 4 methyl benzaldehyde or para methyl benzaldehyde.